So, how many of you have not done math for like 2 years? A lot of you, right? So, I'm sorry, this is going to be fast, you know, but there's 50 homeworks that you need to do before Saturday. I think if you can do those, get on track, then you'll you just got to take it one problem at a time. Don't get anxious about it. Just attack it one problem at a time. There are a lot of helps with the book too. Like the book homeworks have like help me solve it and different features on it that will give you practice problems and so forth. But let's talk about factoring. So a couple of key results I should share with you. A squared minus b squared is a minus b times a plus b, right? This is the difference of squares formula, right? There's also a difference of cubes. Let's see here. I think it's a plus b. No, it's a minus b. Let's see if that's right. So if I multiply this out, I get a cubed, I get the minus b cubed, great. In the middle, I get minus b times a squared, and I get plus aab, which is ba squared. So this times that, and this times that cancel. That's good. I also have a minus ab squared here, and I have a plus ab squared here. So if you multiply this all out, everything cancels out except for the a cubed minus b cubed like you like. So this is the difference of cubes formula. There's also a sum of cubes formula. Let me check on that. So I get a plus ba squared, I get a minus ba squared, I get a minus b squared a plus b. Okay, we're good. Now I have to check it because I don't actually have these like hard memorized. You know, I actually write them down and check them. I know that the pattern's like this, but that's, you know, I don't have like a old sheet of paper I carry around with me with all the formulas. I just remember it to the best of my ability, and then I check it using logic. Right? Okay, so these are some basic patterns we can be looking for as we're factoring. Another thing that we should always keep in mind is just the distributive property, right? So we have a times b plus c. It's ab plus ac. So that distributive property really guides so much of what we're doing. We just apply that over and over again. These are the heart. Well, I mean, I wouldn't say this is the heart of factoring. The distributive property is really the heart of factoring. Because what is factoring? Factoring is multiplying in reverse, right? So let's get started here. Example 1. So let's factor x squared minus 100. How would we factor this? How about this? Let's look at this as x squared minus 10 squared, right? So I can think of a as being x, and I can think of b as being 10 in this difference of squares formula, right? That's the pattern, and so the factoring is x minus 10 times x plus 10. There you go, factored. Okay, that's not bad. I know it's been 2 years, but you probably could have done that even if I hadn't helped you, right? Right? Maybe. Maybe. Example 2. Here's one that you might get hung up on. X squared minus 6. Can you factor this? Yeah. Yeah? Nope. Somehow cancel out the square. Oh,
you write it in reverse, right?
Yeah, I want the square root of something squared here, right? Yeah. It's, yeah, the square root of, right idea, but just put a 6 there. Right? So like, think about this. I mean, this is a very silly comment, but what is the square root of 6 squared? It's 6 again, right? So any number can be converted to the square of its square root. Now, your previous algebra course may or may not have ever covered such a problem. That's why I'm covering it now, okay? So, there are parts of your homework also, I would say, that don't even think about this, especially in the remedial sections, which is the ones with R, or they might think of it review. Not really remedial, it's review. Okay, so anyway, it is the difference of squares, like this, and so here's how we factor it. You could say it's ugly, but I mean, that seems kind of mean. Like, what if a square root was your mom or dad or something, right? I don't know. Should make such square roots are beautiful. But there it is. Yeah. Okay. Another one. How about this? What if we had x squared plus 3x, or minus 3x rather, plus 2? Now this one is not like the first two. Yeah?
I have a question about example 2.
Yeah?
Would it be okay to also factor that one as x times the quantity x minus 6, or is that for a different?
So let me add your question as example 4. And so what you were saying would have been like this example. If I had x squared minus 6x, then I could factor the x out and do x minus 6 like that. So that's a great question. This is my 3rd time teaching college algebra today. This is the first time that pattern's come up. And that's what a good question will do. It'll take the lecture in a direction that maybe we hadn't gone before. It's good. But no, see that you're missing the x on the 6th term. That's why you can't just pull you have to have an x there to start with. And it's really this pattern here, again, going reverse. Like, think of the a as the x. It has to be in both places to pull it out. Yeah. This x squared minus 3x plus 2, how are we going to do that? Yeah.
Isn't it what it multiplies to -3 and, or no, adds to negative, you know what I mean?
So you're saying what adds to -3 and what multiplies to 2. Exactly. So how do we get 2? Either 1 times 2 or -1 times -2, right? Or the square root of 2 times the square root of 2. Oh, we don't talk about that, do we? But you could also do square root of 2 times square root of 2, couldn't you? But we just think about integers here with the elementary factoring, right? Leave the square roots for a later class for the most part, except for this example. So what do you think, 1 times 2 or -1 times -2? I think we want the minuses, right? Because we want the -3. So if we put a -1 here and a -2 there, I think we'll be good. Because if you multiply that out, we get a -x and a -2x, all right? By the way, something I should say in all of my classes, which I have failed to today, except till now, you are freshmen. That means you have been placed in this math class. Do not trust that you have been placed in the right math class. Check on this. Look at your major. Find out what the first math class you get credit for is. If you could be in that class, be in that class, all right? So that's a very complicated question for me to answer for all of you all at once, but there's at least one person in my previous class that I'm kind of like, I don't know, like they had pre-calculus at a community college before they were here, and their advisor just placed them in college algebra. I'm like, I'm not sure that makes sense. If they already had pre-calculus at another institution, that's the course after this one, right? Like pre-calculus is the course, let me put it in less opaque terms for you. Pre-calculus is the course where we have like factoring, graphing very fast for about a half of the semester, and well, about a third of the semester. And then about another third of the semester is logarithms and exponentials, all right? And then the last third of the semester is sine, cosine, inverse sine, inverse cosine, the unit circle, radians, degrees, all that jazz, right? So if these words I'm saying are familiar to you, and you already had those at a college level somewhere else, and you need that class in your major or classes that come after it, then maybe this isn't the class you should be in. Yep.
If I were to take those classes, I did not take the higher, how would I be able to go to a different math then?
You'd have to talk to a professor.
Okay.
I mean, you'd have to talk to like the math chair.
Okay.
You can talk to me after class. I can try to help you.
Very
Yep.
cool.
Now, we want to make sure you're in the right, we want to put you past, like it's also the case, sometimes people have a class at a community college or something, or for example, there's this thing called straighter line, and like pretty much anybody who takes a course in straighter line fails everything after it. So don't do that, unless you just don't need to take anything after it. Just saying. Okay, I digress, but fortunately we have until 4:30, right? Because I started late. No, that was mostly a joke. If I do this till 4:30, my wife will be like, "Hey, where are you?" Okay, so all right, so this was good. This wasn't bad. Let's try another one here. Example 5. Let me find one that's a little bit more persnickety. All right. Come on. It's like the first 18 problems in your homework are factoring. All right. Yeah, fine, that one's good. Oh, did you pan the video over here? 49x squared. So where I was working before this, like last 2 years, I've been teaching at the University of West Alabama. And it's an interesting place, but we had very few students. So some classes I'd only have two students or 4 students. And so I didn't feel right to ask them to do the camera, so I did all my own camera work. And I'm a bad cameraman. Like, I will forget to move the camera. So I'm glad that we have enough people here that we can shift the camera around from day to day. Okay, so by the way, the participation points, I don't think I talked to you guys about that yet, but participation, like part of that's coming to class, doing the top hat, right? Other thing is like doing in-class exercises that I'll probably have like top hat quizzes for those. And also just running the camera, right? So like I'll ask you, hey, did you run the camera? And then you can say, yeah. And then like I'll give you so many points in top hat for that. I mean, I'll give you so many points in the participation for that. So participation, like 20 points assessed. I will assess participation during the quiz. While you guys are taking the quiz, I'll be looking at top hat records and going, okay, Janie has 20 points in participation. Johnny, oh, he ran the camera once and he had a really good question in class and blah, blah, blah. I'm going to give him 25 points in participation just to give him some bonus, you know? Who knows? It's possible. Anybody here named Johnny? Nobody's named Johnny anymore, right? It's a forgotten name. Anybody here named Jail? Jail. I had a Jail. J-A-E-L. No, anybody know this? Do you know who this is in the Bible? Who is it? Yeah, the lady who drives the tent peg through the other guy. Yeah. A violent woman. Like who names their daughter Jail? Like that's rough. It's like, I don't know. Like we named my son Isaac because, well, we thought he would be. It just is. Well, I mean, we named him Isaac, but he's actually very joyful, so it made sense. But anyway, so this one's annoying, right? Because it doesn't have x squared. It's got that 49 x. So I guess we can put 7x, right? We can try that. 16 is what? So we get 1 times 16, or 2 times 8, or 4 times 4, plus or minuses of those. I guess we need some minuses, right? What do you guys think? 4 and 4? Is it minus 4 and minus 4? Is that right? 4 times 7 is 28. 28 plus 28 is 56. Yeah, that's it. So I got lucky. I could easily have burnt 3 minutes of class on that. Okay, so let's look at another one here. How about x squared plus 4x minus 5? You know, this is it's a fancy, beautiful, mostly new campus these days. I mean, when I started working here in 2008, most of those buildings are gone, right? Like they've all been demolished. I mean, this was here. Why don't we have clocks? Like, there should be a clock. You know, like they paint these walls like every year. Paint's expensive. I want a clock. You know, that I could like see. You know, the kind that you guys don't know how to read. I mean, maybe you know how to read. I've been told kids these days can't read clocks. But, I mean, I don't know. I'm sorry, I don't want to impugn you with these kinds of stereotypical comments about, what is your generation called? Gen Z. Oh. Ooh. Under some definitions, I'm a millennial. Really? Not quite. I mean, I was born in 78, so I don't know. It's kind of, Gen X, I don't know. But so what do you guys think? Can we factor this one?
Yes.
Is there a trash can back there?
Yes.
Eh.
Bring it to you.
Yeah.
I did not get it. But eventually. All right, so at least I didn't hit any of you. I mean, I've thrown markers at trash cans like hundreds of times. I've only hit students like three times maybe. So what did I hear?
Working on 4, huh?
Yeah. So did I hear a plus 5? Minus 1? Does that work? So we get plus 5x minus x. That gives us a plus 4x. We get the minus 5. We get the x squared. Okay, we're good. All right. Example 7. How about x squared plus 4x? Almost the same example, but let's make that a plus 5. Can you guys factor this? Can't do it as in, I haven't done math for 2 years, I'm rusty, I've forgotten how to factor, can't do it, or can't do it as in it's a mathematical impossibility. I need some oil. I'm unpacking back. I just bought a house like 2 weeks ago or whatever, and I'm still like 50% unpacked. Like last night, I unpacked like 20, 30 boxes. I got a lot of books. So, got something like, I don't know, 50, 60 boxes of books, notes, something like that. I do math at home, it's true. Yeah, I mean, I'd like to. Sometimes my wife gets annoyed. Yeah, not really. Let's see here. So, what do you guys think? See, it's a trap. I mean, you could spend any amount of time on it. You can't factor it with real numbers. In order to factor this, you need complex numbers. This is what's known as a prime polynomial. So this is a prime or irreducible quadratic. So some of your homework problems will ask you factor this, or if it's prime, say it's prime, right? So how do you decide whether or not a polynomial is prime? Oh, you just try to factor it, and if you can't, it doesn't work? Well, that's not really a very good judge, is it? Because something like this, you could easily get twisted and not be able to factor it just because the arithmetic is hard, right? Fortunately, there is a theorem, and here's the theorem. Ax squared plus bx plus c is prime when b squared minus 4ac is less than 0. So I would encourage you to make this one of those things you put on that formula sheet you're building, right? Some of you guys will ask me, Dr. Cook, is there a review for test 1? Yes, there is a review. Every day of class is a review for the next test. And the quiz is actually an intentional review for the test. I don't write a separate review. There's no need. Everything we're doing is a review for the next test. Okay, so now let's put this into practice. How does this work on example 7? So like if we have x squared plus 4x plus 5, this has a equals to 1, b equals to 4, c equals to 5. These are called the coefficients of the polynomial, right? You remember you use these things for the quadratic formula. We'll get to that eventually, okay? We're not quite there yet. But these are the coefficients. And what happens when we look at b squared minus 4ac for this example? We get 16 minus 4 times 1 times 5, which is 16 minus 20, right? Which is, what is that? Negative 4, right? That is less than 0. That, my friends, is a prime polynomial. Now, if you tried out, what is this thing called, by the way? This is called the discriminant. Because it discriminates what kind of polynomial you're looking at. If we were to calculate the discriminant for the earlier examples, we would have found out that it was either negative or 0. It's 0 in the case it's something like this one here. See, this one we could have written as what? 7x minus 4 quantity squared, right? So that's actually the repeated root case, repeated factor case. Multiplicity 2. So that would have had discriminant 0 in example 5. If we calculate the discriminant in example 6, we would have got what? A is 1, b is 4, c is minus 5. So b squared minus 4ac is what? 16 minus 4 times 1 times minus 5. Minus times minus gives me plus. So the discriminant for example 6 was actually 36, which is greater than 0. So that if you calculate the discriminant and it's positive, you know what that means? That means you can factor it. So go back to work on it. Try some other numbers, you'll get it. All right? But if you're having trouble factoring it, maybe take a second, calculate the discriminant, and if it turns out to be negative, then you know, hey, this is prime. Now you guys aren't going to take my advice because at some point soon, you'll realize that you have many tries on your homework. So you can just hit prime to start with, and if it counts as correct, then you're done, and then you can go back and try to factor it otherwise, right? I shouldn't have told you that. Dang it. Oh well. But there's no like try it again function on the quiz and test, right? So that's only good for so far, right? And I guess I should also mention at some point that you know, there's a big difference between finding answers for the homework and doing the homework, right? Like a lot of people think if I found answers to the homework and I have a 100% homework grade, then I've done the homework. Well, yes, technically, but the point of the homework is to learn the math, right? So if you're just circumventing your learning process by like Googling or checking, or you've got some smart friend who knows how to do math and just ask them all the questions, whatever, you know, you're not learning the math. The only way you can learn math is to do math. It's just the way it is, right? It's always the way it is, no matter how high you get in math. All right, so another example here. Another kind of problem that you run into sometimes is what's called factoring by grouping. All right. Let's see here. So I'm going to come back to this board if you want to pan me back over here. Man, this board does not erase. Somebody must have cleaned it with water. Actually, before I get to my factoring by grouping, let me just give us a simple one of these. X cubed minus 64. Which section are we in? We're section 1, right? Did the attendance sheet get all the way around? Did I hand the attendance sheet out?
Yeah. Some.
It's in the back. Everyone sign that? So how are we going to do this x cubed minus 64? Oh, that's not my pen. Did somebody start passing? Somebody started passing the pen, huh? That's funny. Or pencil. All right. Oh, I should mention. So, if you guys are missing from class, right, for like you're sick or something, one way we could do things would be to run teams, so you could watch the course the same time we're having the course. But if I do that, all that's going to happen is I'm going to open up the laptop, I'm going to join the Teams meeting, right? And the laptop's just going to sit over here. You're not going to be able to see anything I do. And you probably won't be able to hear me that well either, half the time. Or what you could do is just agree with me that you're going to watch the video after the fact. I try to post the video from class the day that we have class, right? And so, you know, I'm trying to record everything we do in here. And so then after you watch it, you just email me and say, hey, professor, I watched the video. Can you count me as attended? And I'll be like, sure, fine. So let's say you're sick or you've got some, like, you know, wrestling meet or whatever. Hey, I got a wrestler in one of my classes. None of you look like wrestlers, but you know, that way we can, I mean, I think it's more convenient for you too, because you don't have to be there during class time to do it. And let's face it, if you're sick and recovering from the flu, maybe you want to be sleeping at 4 in the afternoon, and then like when you feel better, watch 3 classes in one day or something, right? I mean, I would. So if that's okay with you guys, that's what I'm going to do. Yeah? So if it's not, if you really need me to run teams, just let me know. I will try to do it, but I'm not good at it. Are you guys jugglers? Yeah, neither am I. Like, I can really just do one thing. Like, also running, live streaming at the same time, not good for me. It's also not good for you. Like, focus on your homework when you're doing it, right? Don't try to like do your homework and watch some streaming show or something, right? What's this?
That's just the second formula.
And you can see that because what is 64?
It's a cube root.
It is 4
Yeah.
cubed, right?
4 cubed.
4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. Now, if you didn't see that, you could do what? You could take your calculator, you calculate the cube root of 64, and you'll get 4. So like if you didn't have the arithmetic insight, you could take the cube root in your calculator to see what you should do. Yeah? And anyway, once we have that, then we can use this pattern. We've got x minus 4. And then we're going to do x squared plus 4x plus 16. So what I'm doing here is a equals to x, b equals to 4 in this pattern. And here's a pro tip for you. Sorry, I've been watching too much YouTube. This here is going to be prime. Whenever you factor one of these cubics, the quadratic piece in this formula ends up being a prime polynomial. If you don't believe me, you can calculate the discriminant and see it for yourself. One more problem. Sorry to go just a minute over here. But this will be it for today. I'll try not to go over usually, but I did start 10 minutes late. I feel like I owe you guys. 7x squared plus 14 minus ax to the 5th minus 2a. This is that factoring by grouping problem I was talking about. How do we factor this? So, yeah? Split it in half. Yeah, split it in half. Like, look for something common. Like, try to use the distributive property, right? Like, if I look at the 7 and the 14, they've both got 7s in them, right? So I can factor a 7 out of that first piece. I get 7 times x squared plus what? Plus 2, right? That's just coming from these two pieces, right? And then look at the last two pieces. Well, they've both got an a on them, right? Well, in fact, they've got a minus a. Yeah? So why don't we pull a minus a out of that? And then what's left? X to the 5th plus 2. At this point, I realize I've copied the problem down wrong. So what was this problem supposed to be? That was supposed to be 7x to the what? What was this supposed to be? That was supposed to be a 5 there. I'm sorry, guys. This is what happens when you hurry. That is something only I am allowed to do. Once you get a PhD in math, one of the things that you're allowed to do is change problems. When you're taking courses, this is not a freedom that is granted to you. Sorry. I did cheat the system and exercise it a few times as an undergraduate to make problems easier, accidentally. It really annoyed my friends. But anyway, I had this one class, I changed a 3 to a 2 so I could just factor it, and like the professor gave me half credit. And then my friend had worked the problem with the cube, suffered through, and made some small error at the end and also got a half credit. And then he looked at it and he was just like, ah, so annoying. I agree, it was annoying. He should have taken more points off mine. But anyway, that was also a class where I high-fived my friend after we both made 50s on a test because the high score was 70. It was transfer differential equations. I had it with a professor named Fauntleroy. He looked like Morgan Freeman, and he had his voice too. He was very, 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 very cool man. And he was still wearing drawstring pants from like the 70s. Like his wardrobe was still very much 1970s. I had this class in the late 90s. And I love Dr. Fauntleroy. He was a trip. Engineers used to be like, how do you do that? How do you do that? And he'd just turn around, he'd look at them and he'd go, it's just algebra, man. It's just algebra. And then he'd turn around and go back to work. But anyway, so this is factoring by grouping. You have some problems in your homework like it. Good day to you. So I'll stop the recording here. If you have a question about other things after class, come talk to me. Eventually, I'll teach you guys to end the recording.